Hello everyone, welcome to Next Round Coding. Today we are going to solve LeetCode 4003 minimum cost path with alternating directions 3. We will first understand the problem, then go to the approach and then solution. So let's understand the problem. So we have given integer m and integer n and a 2D penalty vector of size m comma n. So there is a grid of size m cross n, and initially we are standing at 0 position, and we need to go to m minus 1 n minus 1, means the bottom right position. Now to entering any cell, suppose we are entering a cell I comma j, this cell, then we need to pay the entering cost. The entering cost is I plus 1 into j plus 1, and from each cell we have 5 choices to move. From this cell we can go right, we can go left, we can go up, we can go down, and we can stay here, right? So we have 5 choices. Now there is a action count which starts from 1, and for after each move it's incremented by 1. So from 1 to 2, for the next move it becomes 3. Okay, this way it goes on. Now if the action parity is odd, then we can move. In the next move we can go to the right or we can go to the down. If the action parity is even, then in the next move we can go to up, we can go to the left. If we go this way, then for going to the new cell we just need to pay the entering cost. If we don't follow this rule, means for even parity, if we want to go right or down, then we need to pay the penalty. If we are standing at I comma j and our current parity is even, and we try to go to down, then the penalty we need to pay penalty of I j, the cell from which we are moving. This penalty we need to pay. Obviously the entering cost will be added also. Now if we want to wait here, we also need to pay the penalty, but entering cost will be not considered, and the parity of the action number change after each move. So if we wait here, the penalty number is also increased by 1, and it will be the parity will be changing. So this way, if we want to go from 0 to 0 to m minus 1, n minus 1, we need to find the minimum cost to reach the bottom right position. This is the question. I hope the question is clear to you. Now let's see the approach. So as you know, we need to go from 0 to n minus 1, n minus 1 with minimum cost, right? So this problem is nothing but a single source Dijkstra problem. We can use the Dijkstra algorithm to find out the minimum cost to reach the cell m minus 1, n minus 1. The things we need to carry in the Dijkstra algorithm, that is the cost to reach the any cell, the cell number I comma j, and the parity, right? These 4 things we need to carry, and obviously if you know the Dijkstra algorithm, we need to take a mean priority queue. So we will take a mean priority queue which will store this thing and pop the minimum cost over there, and also we need a distance array of m cross n cross parity. Parity can be 0 and 1, so it will be 2. This size distance array we need to build, because this will store the minimum cost to reach any cell yet. Okay, this way, using these things, we can implement the Dijkstra algorithm and find out the minimum cost to reach the cell m minus 1, n minus 1. Now we see the code. In the code we will get this algorithm better way. So now let's move on to the code. So now let's see the code and understand the Dijkstra algorithm. So as I told you, we need a distance array. So there will be vector long distance array in comma vector in comma vector of long so comma long max. Initialize it long max. Now, as you know, in Dijkstra algorithm, we need a mean priority queue. As I need to pass four variables, I'm taking a vector of long, there is a of vector of long, comma greater vector of long, PQ. Now, the distance of 0, 0, parity of 1 will be 1 because we are started from 0, 0 and parity is 1. Only the entering cost will be paid over here. That's why it's 1. And in the parity queue, we need to push cost of 1, 0, 0, and 1. That is 1. Right? Now, we need the four directions. So this is a vector of ID dr 0, 1, 0, minus 1. And the vector of ID DC, which is 1, 0, minus 1, 0. Okay. Now let's while PQ not empty or auto cost I and our parity P is PQ dot top and PQ dot pop. Right. Now if we reach the m minus 1, n minus 1 means the bottom right cell, then we just return the cost. So if I equal to minus 1 and then G equal to n minus 1, return our cost, right? It's return. Now our new parity will be parity is our 1, parity will be changed. If we want to stay over here, so if we stay, then if our current cost plus penalty of IMG is lesser than our distance of IJ with new parity, then we can update it. So distance of IJ and new parity equal to penalty of IJ plus cost, right? And PQ dot push our cost plus all specified distance of IJ new parity, and we are standing on the same cell and parity is only changed, right? It's done. Now let's move to the four directions. So for int k equals to 0, k less than 4, k plus plus, int in us equals to I plus dr of k, int in c equal to j plus gc of k, right? Now, if this goes out of bound, so in R is greater than equal to N, or in R is greater than 0, or NC is greater than equal to N, or NC is lesser than 0. Just we need to continue, right? Okay, great. Now we have a entering cost, right? So uh, just name it as long new cost is our current cost, and new cost plus equal to our entering cost. So it will be I plus 1 into j plus 1, right? Now our direction will dir. If our parity equal to 1, then we can go our right or down, right? So dir is equal to 2 if our k is lesser than 2, right? Else uh, dir should be equal to k greater than equal to, yeah. So this means if it is it is that is on, then dir it should be our right or down. And if you see the direction, these two, this first two, you know, right and down. And if k greater than equal to 2, then the last two, left and up, right? So this is done. So if dir is 2, then we don't need to pay the penalty. But if dir is false, then our new code will be added with penalty of I and j, right? Now at the end, we need to check if our new cost is lesser than our NR and C, and our new parity means new parity will be in, right? Then update our distance NR, NC, and NP with new cost and PQ dot push our new cost NR, NC, and NP, right? And here the new cost will be NR and NC, not IJ. This is my mistake. And at the end, we can just return anything. I'm writing a -1 because our main answer will be returned from here, just from here, and it is for the only that maintaining the return type. Okay. Now let's see. We done it. Okay. Okay. Just name it like this. Long cost is error of 0. 1 will be our I. 2 will be J, and our IDP will be our P monthly. And one more thing, we need to check this as well. If our cost not equal to distance of I, J, P. Just continue. Now let's start it. Oh, this is my bad. This should be a bracket over here, and there is also a bracket over here. Now let's turn it up. Yeah, it is running fine. You can see the code. Now try to submit it. Yes, it is accepted. Now let's talk about the time complexity. Time complexity over here is big O of m plus n log of m plus n, because the grid size is m plus n, and as we using Dijkstra algorithm with mean parity cube, it's take mn into log of mn. Okay, and the space complexity, as we are using a 3D array for storing the distances, it would be big O of n plus n into 2. So this is a time and space complexity, and I hope this is helpful to you. Thank you.